for the PoolPak line at Temperature Equipment Corporation. We're going to talk about three major topics today. It's a very complete and comprehensive product line, and we can't possibly hope to cover all this in one webinar within the span of less than 1 hour, but we'll do our best to get through what I have today. This is going to be a continuing series of webinars on the PoolPak product line and pool dehumidification in general. We're going to talk about pool water chemistry today, as well as air distribution. Then we'll get to the PoolPak product line. Okay. Pool chemistry is very important, but at the same time, we have to know where the lines of responsibility are. When we first fill a pool, we chlorinate to a free chlorine level of 1 to 1.5 parts per million. Free chlorine does not evaporate. That is, you can't smell it. It won't come out of the water on its own. No chlorine smell in the pool room is a sign of good chlorine chemistry. We've all been in pool natatoriums. That's what the rooms are called, pool natatoriums. And we smelled little chlorine or no chlorine, and we smell very strong chlorine. If you smell chlorine, there is a problem. As long as the free chlorine stays in that 1 to 1.5 range, the free chlorine will stay in that range of 1 to 1.5 parts per million if the pool is not used. The problem starts when swimmers enter the pool and bodily fluids, sweat, urine, and so on, gets into the water. When that happens, the free chlorine combines with those substances and creates what's called chloramines, and that's where the smell comes from. Once again, we have a pool, and we raise our free chlorine level using a chlorinator to about 1 to 1.5 parts per million. Everything is good so far. That's the total chlorine. When people enter the pool, when other matter makes it into the pool, that's when it combines with a free chlorine to form combined chlorine or chloramines. And we're okay with that as long as it's below 2.2 parts per million. Once it gets above 2 parts per million, that's when we start having problems. That's when we have the smell of the chlorine, eye irritation, lung irritation, respiratory problems can occur as well. When we get combined chlorine levels exceeding that 0.2 parts per million, it can evaporate into the air and condense on materials, walls, windows, pool hardware such as the pool dehumidification unit or other metals in the pool area or in the mechanical room. Problem, when that condensation occurs, we have a couple of problems. One, it's a rather corrosive liquid, and that will attack metallic surfaces in the pool area, in adjoining rooms if that air makes it to there, and it can cause problems for the swimmers as well. When those chloramines make it onto metal surfaces in the pool room, it's going to start corroding it. It can even attack stainless steel, which is one of the more durable metals out there and frequently used in pool areas. But good pool chemistry is necessary to protect that metal. And of course, it can cause problems with the swimmers, respiratory, eye irritation, stinging of the nose, and other problems. So how do we get rid of chloramines? We have to shock the pool. And what does that mean? What we do is we raise the free chlorine levels to 10 times the combined chlorine level. And that will break down the chloramines and allow us to evaporate some of those compounds out into the air to be ventilated by either purging the natatorium or increasing the ventilation level of the room. It's a complex process. Here's what it looks like. Pool managers are well trained in this, and again, this is their responsibility. It's a team effort. We take care of the air in terms of heating, cooling, dehumidification, and ventilation. The pool manager and the owner are responsible for taking care of the water. And again, once we have a problem, we do have to increase that chlorine level to 10 times the combined chlorine level, and that will force some of the chloramines and other substances out into the air so they can be ventilated out of the room or purged out of the room via the PoolPak unit. We're all familiar with filtration systems that have been around for a long, long time. There's some new technologies that are making it out into the market. One is the saltwater pool. Rather than relying solely on chlorine, saltwater pools rely on an electrolytic cell that combines, that takes the salt that's introduced into the water, and we form chlorines by removing the sodium molecule from that salt molecule. Another technology is ultraviolet. This automatically controls chloramines to less than 1 part per million. Owners claim UVs are almost maintenance-free. I was just talking with a coworker whose children are heavily involved in swimming at their high school, and since they converted to a UV system, their problems such as excessive use of chlorine have decreased dramatically, and also problems, respiratory problems, asthma, cases of asthma, swimmer's lung has decreased dramatically as well. It costs more. First costs about twice as much as standard chlorinators, but you save a lot of money on chlorine, get more for your money out of it, and we minimize or eliminate shocking in a properly managed pool. This is what an ultraviolet device looks like. You can see the water pipe going to and from it. And what we do is there's an ultraviolet light inside it. The water passes through the device and exposed to the ultraviolet light in the appropriate intensity and duration, and it breaks down chloramines. That device that you see on the bulb, it's sort of like a little carriage that goes back and forth and cleans that tube if necessary. There's a sensor on there that senses how much light is coming off the UV bulb. If it decreases, then the carriage moves back and forth to scrub deposits off that bulb and restore the system to a better operating condition. Another option is ozone systems. Again, more expensive than traditional systems, but you require less chemicals and less treatment of the pool. Proper pH is another thing that we have to, that the pool manager has to look at and monitor. Neutral is best. We need to remain in that 7.3 to 7.8 range, and that's where you get the most out of your chlorine, and that's where the swimmers are going to be most comfortable. If you get too acidic, you're going to use more chlorine because it isn't as effective in an acidic pool. It's also more corrosive and irritating to swimmers. If that number goes, if the pH level goes above 7.8, again, chlorine is not as effective. You're going to use more of it. Scale will form on the surfaces of the pool, on the tiles, and so on. And again, it's irritating to swimmers. So why are we talking about this, about water chemistry? We want, again, to delineate where the responsibilities lie for proper pool management. There's the air side and there's the water side. With PoolPak units, we will handle the air side very well, the dehumidification, the cooling, the heating, and ventilation. But if we don't have proper pool chemistry, pool water chemistry, then the PoolPak unit will not be able to do anything about that, and we could cause damage to the structure due to corrosion. Could create an atmosphere that's just not good for swimmers and other people using the pool, including spectators, and they're just not going to have a pleasant environment to swim in and to watch the swimmers. So again, bad pool water chemistry. It's going to corrode almost anything that's metallic, including stainless steel. And it's also going to make some bathers ill, especially those that are more susceptible to harsh environments. Sometimes owners are under the misimpression that PoolPak should scrub chloramines out of the air. That is not what a PoolPak unit does. It just dehumidifies, cools, heats, and ventilates the air, the natatorium. We don't remove or put chemicals in the air, and owners need to know. So engineers, have a discussion with your clients. Ask them about their pool maintenance procedures. If you can, talk with the pool manager, the person who's actually testing the water, monitoring the water, and treating the water. And again, if we want to eliminate chloramines, the pool water chemistry must be controlled and monitored and controlled properly. Now, air distribution. Sometimes we'll be going into a replacement situation, but certainly we'll be getting into other jobs where new pool structures are going to be constructed. Air replacement situation is kind of an old school treatment of a pool natatorium. Sometimes the ductwork was put right over the pool, and here we have a situation where we're blowing dehumidified air right onto the surface of the water and reabsorbing water. That's not what we want to do. What we want to do is wash the walls with the airstream, keep condensation from forming, and keep the air moving around so chloramines, if occurring, do not settle on the walls or condense on the walls or on the deck. We also need to treat the windows with a good stream of dehumidified air. So place your ductwork so we wash the windows so condensation does not form there. And then you can return the air to the pool dehumidification unit with a common return. Here's another example of a means of washing the skylights on a roof that's constructed mainly of glass and metal framework. Where you have structural members that may be adjacent to exterior walls, we need to make sure that we have good airflow across them as well to make sure that we don't condense water and chloramine onto the space. And of course, windows and doors must be treated as well. Here's a local example. This is at Hamburger U in Oak Brook, Illinois. Very good distribution system, washing the windows, the skylights, and even in an area where ductwork could not be installed, a baseboard heater will do a fine job of keeping that area free of condensation. We recommend a perimeter type distribution system. Below ground air distribution also works well. Since warm air rises, we have an easier job of washing the windows with a good stream of air. High supply air distribution, as long as it's properly constructed with appropriate diffusers, we will get flow to the windows and to the deck and achieve proper dehumidification of the structure to protect it from damage from excessive humidity. Another common situation is a high school swimming pool where you might have both swimmers and spectators. different ways to treat these areas. The pool dehumidifier in this case just treats the pool area, and since we have a glass partition in between the pool and the spectator area, and we have a dedicated unit to the spectator area. Where you don't have a partition, we can also zone by type of unit. We can rely on the pool dehumidifier to dehumidify the pool natatorium. And then on an outdoor unit, gas-fired, to treat the spectator area. This is what commonly happens, of course. We have a pool dehumidifier treating both the pool area and the spectator area. It's acceptable. It works. Just, it's the least expensive way to do it. That will get the job done. Duct materials. Don't need anything extravagant. Galvanized steel, spiral duct, rectangular duct with epoxy coating is just fine. Aluminum with epoxy coating is very good too, or plastic or fiberglass. Fabric ducts, not a superior solution. As a matter of fact, we're just not sure at this point. The duct becomes a filter for dust and other things, and over time, it's going to start getting, the dust will collect in the orifices that are cut out of it for airflow, and static pressure will increase over time, and that might throw the fan into a bad region of the fan curve. In natatoriums where we're starting and stopping the airflow, we can have the dust bomb effect on reinflations. If they're not installed properly and fastened properly, they can rotate out of position over time and throw the air at some other place, in other directions rather than where it should be going, washing the walls and the windows. They're also difficult to balance. Again, the diffusers, diffusers are not typically used in duct socks or fabric ducts, and so the airflow is difficult to manage and to balance. And ideally, if you're going to use it, you should use directional diffusers to make sure that the air is thrown down the windows, down the walls, and to the deck. Here's what we're talking about with fabric ducts that may or may not get the job done. These perforations, you're not going to get any throw. You're just going to get a wafting or a weak flow of air out of this sort of fabric duct. If you use fabric duct, we should have nozzle diffusers in there so we can direct the air where it should go. So this would probably work a little bit better. Just some standard air distribution considerations. Make sure that we're not short-circuiting the air right to the return grill. And make sure you wash the windows and the doors and the walls with dry supply air. Don't return air through the locker room. This sort of thing can happen. It's still, even though you dehumidify, even though you might have proper water chemistry, you still have warm, moist air going through the locker room, which will attack metals, including stainless steel. Vapor barriers are very important. You must make sure that you use them as you would with any well-designed building. Vapor retarder goes on the warm side of the wall. You don't want it on the cold side, otherwise you're going to get soggy insulation. Windows. You should use windows with thermal breaks in the frame. Be careful about using structural steel that runs from the outside to the inside, as shown here with this lintel. The cold is just going to be conducted right to the inside, and we will be forming frost on that lintel on the inside. Okay. Let's talk about the PoolPak units now. This is their traditional line. It consists of the PoolPak, which is meant for smaller pools with tonnages ranging from 1.75 to 12 tons. Then we have the S series in its various configurations, and the SR, which we'll talk about a little bit later on. The S series ranges from 15 to 80 tons. Okay. The PoolPak comes in two different versions: the AW, which treats both air and water, and the HCD, which does mainly dehumidification and heating, as well as cooling, but it's really a very good dehumidifier option. It comes in both horizontal and vertical configurations. Applications, wherever you see a pool, as long as it's properly sized, we can use the PoolPak. Residential, hotels, health facilities, physical therapy facilities, community recreation centers, and so on. Sequence of operation is pretty simple once you understand it. The refrigeration circuit is energized when the RH goes above the set point or the space temperature goes above the set point. We activate the compressor and run it through the condenser reheat coil. Airstream comes back, and here's where the dehumidification occurs in the evaporator coil. Now, after the air runs through the evaporation coil, it's going to be dehumidified, but it's going to be too cold for reintroduction into the pool. So what we do is we have a reheat condenser or a hot gas reheat coil immediately downstream. That's the white coil right here. If we cannot heat the air to an acceptable level just using condenser reheat, then we can also bring into play an auxiliary heat coil. It can be hot water, steam, or we can also use electric coils, or an exterior gas duct furnace, for instance. Now, the recycled energy, we can use that to either reheat the airstream, as I just described, but if the space temperature is to an acceptable level, we can also reject heat to the pool water. We can heat the pool water using this pool water condenser right here. We'll be piping water from the pool to the pool water condenser, picking up heat from the DX piping, and then reintroducing it back into the pool. This is a fairly standard setup for a PoolPak unit. We have our PoolPak unit right here. We can field fabricate and install an economizer to the PoolPak unit to introduce outdoor air and take care of free cooling when appropriate. We can reject heat, as I said a little bit earlier, to either the pool, or we can reject it to a remote air-cooled condenser. And then, of course, we have our ductwork that goes supplied to the pool natatorium, then back to the unit. Pool compacts do not have integral exhaust fans, so to maintain proper ventilation levels, a dedicated exhaust fan is required. Another standard feature of the PoolPak and all PoolPak units is a cold surface temperature. This is how we control PoolPak units. Okay. PoolPak can handle anywhere from 250 square foot pools up to 2,250 square foot pools. There's some judgment required in its application. The ratio between the pool area and the pool natatorium volume can result in using a larger or smaller unit as required. And this is something that we do at TEC. We will make recommendations. We will select the PoolPak units for you for jobs for replacement or new construction jobs. And where we run into a tough situation, an unusual situation, and it does happen, we go right to PoolPak to ask their assistance in designing the PoolPak unit. Standard control on the Pool Compact is this device right here. It's relatively simple from the user interface buttons that you see here, the raising, lowering the temperature, and it can also be programmed for the set points at the user interface, and it can also be integrated into a building automation system. Here's a picture of the cold surface temperature. You locate this cold surface temperature on the coldest surface in the room, and as long as you do that, as long as we're keeping that surface free of condensation, the rest of the room will be fine. Here's some of the optional features of the Pool Compact. To accomplish heat rejection, we can either reject heat to a remote air-cooled condenser or to a water-cooled coaxial condenser, and that's our pool heater. Outdoor air on the top of the horizontal units, that's controlled or adjusted by using a manual damper. The economizer option, this would just be a pair of dry contacts on the PoolPak unit, and that can control your field fabricated, installed, and supplied dampers and actuators. The PoolPak coils can come in copper tube and copper fin, and we also have two different coatings available. One is the High Core Blue, which gives you a 5-year warranty, and then the CoilGuard Plus is a 10-year warranty, unconditional. We can also network multiple units together to treat, let's say, a pool room that is too big for one pool compact. Maybe it's appropriate that you put in two, so you can control both of those off of one control. These can be mounted inside or outside. When you go outside, it's only available in a horizontal configuration. And you can, remote communications are available via internet with remote access point, with a remote access point option. Auxiliary heaters, you have a few choices here. You can heat using hot water, electric, or gas heaters. The hot water or electric is factory installed. Gas heater is field supplied and field installed. In this case, you would just use a fairly standard duct furnace. Highly recommend that you use stainless steel heat exchangers. We also have roof curbs available for the horizontal, either indoor or outdoor mounted units, compressor sound jacket, and then for non-pool applications where you might have a lower return air temperature, we do have a sensor that can allow you to do that for maybe other processes, industrial processes where it would be appropriate to use a PoolPak unit. Printing facilities also might be a possibility there. Okay. Here's what the Pool Compact looks like. All the major components are mounted outside the airstream. That protects them, gives you better service, better reliability, longer life. So we have the major components, of course, are the compressor, shown here, and then the supply fan motor here and here. And on the AW, this is a vertical unit. That's a pool water condenser, again, out of the airstream, makes it last longer, more reliable, trouble-free service. Air patterns. There's a variety of air patterns available. A little bit limited on the vertical, but that's just the nature of the equipment. You're going to have return air on one side, and you can supply either top or front. The horizontal is a lot more flexible. Return air can come either in the end, the top, or the bottom, and then supply air can go either end discharge, bottom discharge, and here's our outdoor air intake here. Service access. It's good to have access from both sides. I've been in more than a few pool maintenance rooms over the past 3-4 months now, and it's usually pretty tight quarters. So it takes a little bit of imagination sometimes to create service clearances on both sides for the unit. You know, and depending on your airflow direction, you can make sure that the control panel, the access panels are on the correct side. But again, if you can create enough room in the pool room in new construction situations, that's the best thing for proper maintenance of the PoolPak unit and providing access for the technician as well. Again, locating the cold surface temperature, put it by the coldest surface that's in the pool room. Again, if you can keep that surface free of condensation, the rest of the room will follow along and be just fine as well. The controller, pretty powerful actually. It's as simple or as complex as the situation requires. Non-volatile memory, so if you suffer a power outage, your settings will still be in the unit. You can control space temperature, humidity, pool water temperature, and also reads your cold surface condensation sensor. It also protects the equipment from short cycling. You can network multiple units together, and you can have remote access to the unit. Variety of different communications protocol, LANWorks, Modbus, and then via internet, it becomes a remote access point. If you have internet access to it, here's a typical screen showing the set points and actual conditions. Okay. Another option or feature is double wall construction. That's required on outdoor installations. Again, here we're showing that the major components are the airstream, the compressor, and the motor. Here's the outside air opening with the manual balancing dampers. Again, you would to exhaust the air from the pool natatorium, you would have to have a dedicated remote exhaust fan. Here's the return air sensor and the RH sensor. Again, we need to know what the conditions are of both the return air and of the return air and the outdoor air to properly control the unit. This sensor must stay there. You cannot remotely locate it down in the return air duct. Leave it right by the unit. That's the way it's programmed to work, and that's the way it's going to work best. Here's a picture of the coaxial tube-in-tube pool water condenser. Essentially, we have a DX tube running inside a water jacket, and that water jacket comes to and from the pool, and that's how we reject heat and heat the pool using recovered energy. Okay. Another version of the pool compact is the roof pack. In this case, we have a horizontal. That would be the HCD, but it comes with a optional integral air-cooled condenser. Comes in two sizes: 10 tons with air flows and heat capacities and moisture removal capacities, and 12-ton. You can handle pool surface areas from 1,200 to 2,500 square feet. It's a wide variety of applications to different pool natatoriums. Less expensive than installing the individual components, your PoolPak unit, air-cooled condenser, and other components. Less wiring, less power, no DX piping to be done. and it's competitive against other systems out there in the market. Again, the major benefits are it's a single crane lift. You get that you get that factory quality control out in the field. You don't have any piping to do. It's run tested in the factory. And again, you're bringing factory quality control to the job site in a very, very complete, neat package. So other benefits are you're going to save engineering costs. So instead of having to calculate for structural steel for the remote air-cooled condenser, for power and other components, everything is in one place on the curb for the roof pack unit. You're running power to that one space, to that one site, and you're also running control wiring to that one location on the roof as well. You eliminate the remote air-cooled condenser. You don't need the auxiliary furnace. We can build it in. There's no piping. It reduces refrigerant charge because you don't have the piping going in between the unit and the air-cooled condenser. And finally, single-point power connection. And again, as noted here, electric heat requires a separate connection. Again, greater reliability because you get that factory quality control out in the field, and you eliminate a lot of problems that can occur during assembly, contamination to the system while you're piping, and fewer service issues due to that greater reliability. Quite flexible with the return and supply air configurations available. Okay. And now, going on to the final piece of equipment that we'll be talking about today is the S-Series. Let's go over the various components in the S-Series. You have your evaporator coil. This is where the dehumidification and cooling occurs right here. We're bringing in return air through the evaporator coil, cooling and dehumidifying the air. You can also mix at this point with outdoor air from the outdoor air damper. Now from there, again, the pool is going to be dehumidified, but it will be too cool for reintroduction into the pool. So we bring the temperature up to a more acceptable level using the hot gas reheat coil. That's right here. We're taking hot gas directly from the compressor, and we're rejecting the sensible heat into the airstream. We condense it and subcool here in the hot gas reheat coil. If the air is not up to an acceptable temperature at this point, we can supplement that with heated water in this hot water coil. By the same token, during the cooling season, if we need additional cooling, we can run chilled water through this auxiliary coil as well. Again, common construction feature of the PoolPak units, compressors and other major components are out of the airstream, and this is the S unit, and that refers to the supply fan. This only has a supply fan. So if you need dedicated exhaust, you're going to have to provide a field installed exhaust fan to accomplish ventilation requirements. The SE refers to the fans again. We have a supply fan, and if you notice, we have an exhaust fan here now. That's going to be a fixed volume fan, and this will take a portion of the return air and exhaust it to the outside. Otherwise, operation of the unit is very similar. We're running through the evaporator coil to dehumidify and cool the air, and then adding sensible heat via the hot gas reheat coil, and then the air continues on to the pool natatorium. The SEP, many of the same features as the previous two units, the S and the SE, but in this case, we've added a purge fan. Purge fans are used during when you're shocking the pool. You need to get rid of that air that's chloramine rich. So you're bringing out the chloramine from the water, and when you're shocking the pool, you want to purge that air through. Another purpose for using the purge fan prior to swim meets, prior to events, if you just want to freshen the air. Some pool managers use this, say, every 24 hours just to bring fresh air into the pool area. Caution here, of course, we suffer pretty severe winters up here. When you're purging, make sure that you have enough auxiliary heat to maintain control of the building. Another addition to this unit that we didn't see on the previous two, again, major components are out of the airstream. There's the compressors, but here's the pool water condenser, again, out of the airstream. Here's what the unit looks like. Nice, clean construction. These are our evaporator and reheat coils. These are copper thin, copper tube. And again, the compressors, PoolPak has standardized using Bitzer compressors. And we have a cleanable pool water condenser. This allows you to maintain the pool water condenser and make sure it doesn't get clogged up so it operates efficiently. Another feature on the unit that we just looked at is the addition of heat recovery coils. The HR unit has a coil before the exhaust fan, and what we're doing here is we're taking exhaust air going through the coil, exhausting outside. There's piping running between that exhaust air heat recovery coil and the outdoor heat recovery coil, and we circulate a glycol solution between the two to pick up heat from the outgoing exhaust stream and reintroduce that heat, and that allows us to temper the air coming in from the outdoors. And that completes our presentation for the day here. Again, I'm sorry that we had those audio difficulties early on. Are there any questions? Okay. Well, I'll hang on here for the next 10 minutes or so. If you have questions, if you'd like to type them into the chat area, I'm glad to field those as best I can. But thank you for your time.